Awesome. Thank you so much for coming, everyone. We've got a full house. We sold out yesterday, so great. Yeah, great to have you all here. From what I saw, almost about half were new people. So can you put up your hand if you are a new person? You might just be using a new email. No, that is definitely half. Wow. I've talked to a few of you about how you heard about the event, and it's great to hear about a lot of referrals from friends. But hi, I'm Mikayla. I host this event. I think this is probably the 25th event I think that we've run. I've took over doing this 3 years ago. So great to have you all here. Awesome. So yeah, let's get started. So this is Nerd Night, which is a bit different. Instead of 3 speakers, we have 7 speakers from all of you that are just making fun projects in their spare time. Awesome. So first of all, thank you to Outset, which is the lovely place we are today.
Hi there, I'm Reid Stokes. I'm one of the residents here at Outset. And yeah, it's an amazing place to be. There's 3 things that Outset does. The first thing is the space. So if you've got a deep tech company and you're looking for some space where you can build your lab, your engineering, or anything like that, then we've got space here. The second thing is venture capital. So yeah, Outset has got Outset Ventures, and so they're looking at investing in deep tech startups, whether they're based here or elsewhere. Third thing is the community. So this is our community space here. So at lunchtime, this place is packed out. There's people everywhere. It's great, and it's just seeing those discussions going on. Oh, you should go and talk to that person, or have you tried this? So that community part's really important, and that's sort of where I'm involved. So yeah, so hosting the events here ends up with that well.
Awesome. Thank you, David. Loon Digital. So they're an embedded systems expert specializing in high-tech, IoT, and wearable solutions. For the past 10 years, Loon Digital has been assisting visionary companies with hardware design, electronics engineering, embedded software development, and technical advice. They excel in optimizing battery life, boosting power efficiency, enhancing wireless connectivity, and creating scalable, future-proof systems. Thank you, Edith, and thank you, Loon Digital. And next up, we have Triode.
I'm Nate from Triode. We build electronics. It's simple as that, from PCB assemblies, enclosures, the full mechanical assembly, testing, conformal coating, anything in between. And we work anything from prototypes through to full-scale production, startups to established companies, medtech, agritech, bioengineering, just anything someone designs. And we really love solving problems. So when people come to us and they're working to develop something, we like getting stuck in there, find ways to make it more cost-effective for you, make it work, improve their quality, and just get it done for you. Okay, 60 seconds done?
Yep.
Nice.
Awesome. Thank you, Nate. And thank you, Triode. And last of all, we have Braymac.
Welcome, nerds. Yeah, my name's Morgan. I'm from Braymac. We're actually a global electronics distribution company. We can do everything from board-level components to full kind of server AI computing clusters or whatever you need. I just wanted to have a little talk about my personal experience as the field application engineer. I am really privileged in that I get to go around New Zealand and go into companies, and they talk to me about the projects they're working on, sometimes stuff that isn't in the public eye, and I get to do my best to try and help them and offer something back to them, and I think it's a real privilege. And and so if there's anything we can help you with, feel free to reach out to me and I'll see what I can do for you. Thank you.
Awesome. Thanks, Morgan. So yeah, we couldn't run this event without them, so thank you so much for your sponsorship. Awesome. So now on to the presentations. I will give a very quick one about myself, which I reused from last year. But half of you are new, so you haven't seen it before. So anyway, hi everyone, I'm Mikayla. This was me when I was a kid. I used to hate STEM. I was really bad at maths and science at school. And then my dad, which is David here, took me along to a robotics competition against my will. I did not want to go because I thought robots weren't very cool. And I discovered that they indeed were awesome and are really cool, and I wanted to make them. So then I started making those when I was 12, I think was when I started. And then after that, in year 11 and year 13, I got into inventing for the inventing competition Bright Sparks, which unfortunately is not around anymore. But yeah, so I think I made so this one is a hydroponic vertical garden that I made. that was meant to use sensors to detect like the water level, the amount of nutrients. Unfortunately, all this did was flood my parents' garage with water. It wasn't very effective. But through doing this, I also entered it into Young Enterprise, and I got sent to Chile to go and pitch my invention I had made. And this then led in my first year of uni to now being on children's television. I don't know how that happened. So I was on 2 different TV shows around science communication with kids. So this one is with the YouTuber Joseph's Machines. He makes Rube Goldberg machines. Usually he's kind of more like in character and kind of like mime-like, but this was more of a kids New Zealand TV show. So we made Rube Goldberg machines to solve Kiwi kids' problems, but most of the time we made them worse. And then I was also in another one, so that's that show. And then I was in another one. Has anyone seen Let's Get Inventing a few years ago? Yeah, that's Dr. Robotech. So I ended up being on the show Fanimals with him, where we made a robotic gorilla. And so we ripped it open, stuffed it full of robotics parts, and then went and traumatized some kids at a petting zoo. So that was pretty fun. And then I did mechatronics engineering. Not as cool. And yeah, so I make cool things. So when I was at uni, I made this light-up dress. So this was the first prototype. That was the second prototype. The second prototype has about double the amount of LEDs. And the first time I turned it on with a power supply, it melted all the wires because I was using jumper cables and did not realize that sending that much current through it was not good. And I 3D print earrings. These are some cheese, some eggs. I'm wearing the eggs right now. I made some blue cheese. I thought that was pretty funny. And now I work for Crown Equipment. So this is a forklift. You can essentially make it a gigantic robot by strapping a bunch of sensors and making it autonomous or some form of sensing. So that's what I've been doing for my day job since I graduated uni. And I run this for fun as well. This slide deck was literally stolen from a different presentation I did for high schoolers, so ignore that. That's a picture of me pretending to destroy a robot with a hammer. Awesome, cool. Thank you, everyone. That's me. Come chat to me later if you think any of my wacky things are cool.
Firstly, I'd just like to say how cool it is. Been here 2 minutes, and I've never been here before, and already met so many really talented people building cool things. That's what this is all about, I guess. And really cool to background for me, super quick. My name's Michael. I used to work in funds management, so I used to run money at one of the KiwiSavers. And I've worked at funds that manage 1 to 2 billion Kiwi dollars. So I know all the New Zealand listed companies and things. And it's amazing to come and hear about these other businesses that are doing really cool things in New Zealand that you never see when I used to work as a kind of capital allocator. So I recently stopped work and sat down one day and was thinking, what's the single biggest problem in my life? And I was like, man, this cat just keeps shitting in my lawn every day, and it was just killing me. And then there was like this territorial pull-off between 2 cats, and it was just doing my head in. So then I was like, well, I've got to do something, and I didn't want to kill it. Like, I could have just put Panadol out or something. And I thought, no. I'll do this properly. So I'm Googling it, go to Mitre 10, I buy $100 worth of product that doesn't work, and I'm that crazy guy running around throwing like mustard and chili in the garden and like getting nowhere. So then I go down the rabbit hole of buying a bunch of stuff off AliExpress, and kind of here we are. So this is the punk here who thinks he owns the place. And but there's a minor problem in that I have no experience. I've never done this before. As I said, I used to trade stocks for a living. But I went from it's been really fun going from buying stocks in, say, like NVIDIA, Micro and SanDisk and things, to thinking about, like, how do you build something? How do you design? Like, I've never heard of Onshape before. So I was like, well, what do I need to do? I need to kind of do what I always used to do in the stock market. Take a massive problem, look at it end to end, and think about, okay, well, I need to segment it into tiny little micro experiments to see how far I could get along. And de-risk the project and make it appear that I had some tangible evidence to my wife that I was actually doing something with my time. So the first thing was I got this 2-year-old boy, and he's just awesome. And so I was like, oh yeah, let's make a little electric train. So this I just did this, and I don't know, can't remember how long it took. Probably spent 5 hours doing R&D on the wheels because he just rips it apart within 3 seconds of playing with it, which is quite a lot of fun. Very proud that I can say that my boy, one of his first words is robot, and he says it with a Spanish accent, so it's robot. Even today, it was pretty. Anyway, so I thought while I'm waiting for all these bits and pieces to come from China, I thought, what's the second hardest thing to solve? And, geez, I've never done an AI model before. I don't know how many people in the room have, but Edge Impulse, really cool tool, free for hobbyists. I wanted to learn about it. And I was thinking, I've gone from looking at, as I said, NVIDIA GPUs with hundreds of gigabits of data. How can you run an LLM, da-da-da? But how do you do inference at the edge with, incredibly fast enough to turn a turret to shoot a cat? But, I'll get into it. So this was kind of creating simulated data. I mean, it's hard to get photos of an actual cat in my lawn when he's only there for 30 seconds to do a dump and then run. So I had to do what everyone does and use like Gemini to simulate the data to plug it into Edge Impulse. So one of the key things, this tool's so cool. And if anyone's working on a commercial problem that actually is real and wants to solve it, I'd love to chat about how, building out doing this properly, because I just did it. A very small amount of data, and as you know, garbage in, garbage out to any model. So if you don't have a good data set, and annotating a data set like this is painful. Anyway, the real key insight here is that actually my model underperformed an off-the-shelf model, and part of the reason was that it knew what a cat was, but it wasn't confident enough what it wasn't. So it could look at something, but it couldn't actually say with a high degree of confidence what it wasn't. So that's why it's kind of, I thought, a really interesting takeaway. Anyway, Edge Impulse, check it out, really cool tool. So the next thing was like, all right, well, I need to create a vehicle platform. So I started tinkering with this. Meccano wheels are so cool if you haven't played with them, because they can spin in a circle. And I had to create a controller, and it's really cool, ESP now with an ESP32, super cool, lightweight, super fast, anyway. But as you can see, a turret on the right, and that was turning around. I put a TOF sensor on the front and started doing SLAM, which is simultaneous location mapping. So that's pretty cool. So it was mapping out my house. I put a camera on the front for fun. But then you could see it was starting to get a bit heavy when I put the pump on. That's a water pump for the turret. I spent a month doing like turret design. It was a ridiculous waste of time. But then I thought, right, I'm just going to separate out the turret, put the camera on it with a yellow lightweight model, which mind-blowing that it can work on 3 megabits of flash. It's crazy. And it's all because they quantized the heck out of it, but super interesting story separately. But anyway, I used the Seed Sense, the ESP32 S3. Found it pretty frustrating because all it could do is give you like a yes, there's a cat, and I would only want to shoot it if it was 70% likely it was a cat. And I ended up killing it because I added live streaming. This one, the photo there's on the left is, I was trying to get some video footage. Like it sprayed the cat, but I needed evidence of it happening.
I thought you meant you killed the cat.
No.
I killed it.
No. Unfortunately, it's still around. Because I broke the camera, and I've gone and upgraded it. Because one of the realities with the lightweight camera, I mean, that's $15, 20 Kiwi. Incredible that it can do inference. It can do like 1 frame per second. So it's just too slow. It was a bit rubbish. And anyway, I went and bought a Groove AI V2. This thing's got 16 megs of flash. It's got it's got an MPU dedicated to doing edge inference, and it does. I arrived yesterday, so I had a couple of hours running out of time. Seriously cool bit of kit that I'm only just used to. So it sends you 4 bits of data. It sends you an X and Y location for the box, top left with a height and width. And so what you can do as well, what I will do, is use that to approximate depth, because the rough width of the size of a box for a cat. So how high do you aim the turret? So that's actually quite a cool little hack. And I'll put an Arduino Uno on there just for fun, with 4 gigs of RAM, so that'll be fun. Just having fun designing an Unshape. You learn. This one I get asked all the time. Mindful of time, so I'm rushing. AI tools, I always get asked what I'm using. Always get asked. I've been doing this for a couple of months. Visual Studio with Platform.io, wicked unlock if you haven't tried it, because it keeps all your secrets around things like Wi-Fi, passwords and stuff. It keeps it free, secret from the agents, from your AI agents. So it's really cool, because you basically program that in, and then you just, every time you're flashing, it uploads all of your secrets. It's cool. But also wicked, because it's got all the libraries, so it's super smart. But Claude sucks now, and I've gone full. Gemini's real good with real-world applications. They get physics. Codex 5.5 is wicked, like it's so robust. That's that. And then, yeah, just what's next? I mean, I've kind of gone down the rabbit hole a bit now, and I've started doing my I don't like sweeping, and I have to because I've got a 2-year-old kid, and I'm trying to make this like little sweeper robot that's already I'm already 3 generations in. This was only a week ago. Yeah, no cats were harmed in the making of these robots.
Thank you for clarifying that. None were killed.
None were killed, definitely not. But he hasn't come back, so I need to put food out so he comes back so I can shoot it.
Need to train your model more.
Hit me up if you want. Feel free to connect. I've helped a couple of companies, 18, get access to R&D tax credits, and so if you want some help, I can maybe do that on the side. It's not my core focus. I want to build robots.
Awesome. Thank you so much, Michael.
I'm just wondering if you tried talking to the neighbours about the cat.
Oh, absolutely aware that there are much simpler methods.
Have you showed them what you've been working on and all of this?
Yeah, and it's funny because I started this as a joke, and I've already got 5 people saying I'll buy one. And I think this cat is a menace.
My team was called the Control Freaks. They're not here today. That was them. I'm Vibhaa. I'm a 3rd-year engineering science student at UOA. And I participated in PSAT 2026, which was under the Auckland program for space systems. Yeah.
Yeah. Oh, no, flip it around. That arrow.
Oh, okay. Yeah. Sorry, I've never used this before. Oh. Okay, there we go. Oh, that's my lovely team. They couldn't be here today. This is us on launch day. The photo on the right is our rocket after the retrieval. It was a success, so yay.
Woohoo.
This was our reference design. It was a small payload that fit into a rocket, and it was retrievable. So the rocket kind of opened up, parachute came out, and so did the payload. It was based off of Jinx's smoke bomb. Is everything all right? Yeah. It was based off of Jinx's smoke bomb, which was the first bomb that she made. And it was also like one of us, like our first serious project going into engineering, so we thought it was fitting. But
Based off the TV show Arcane, right?
Yes,
Yep.
yes. Sorry, I should have mentioned that. So this was our internal design. We 3D printed our main body and the cap. So the main theme was retrievability. It was a vapor system, so we had vapor and it escaped from the top so that we could visually see it. It was very similar to a vape, but we did make everything ourselves. Like we designed the chamber and the nozzle and the nichrome wire, so we designed everything.
So you all know how to make vapes now, I take it.
Yeah, basically.
Side hustle.
We've got the cap, the nichrome coil. So the nichrome coil was attached to the wick, which was fully saturated in the vapor solution. Not the vape solution, the vapor solution. And the nichrome coil was then heated so that the vapor could be produced, and it escaped from the nozzle. We had 3 batteries because we had a lot of current, so we had a lot of batteries. We also had our avionics system, which was 3 PCBs. I think that's next. Oh, this is our testing. We tested like many different coils, mesh coils, different wicks. We did volume testing. Basically anything that you can think of, anything that would like optimize the performance of our payload. In the middle, I don't know if you guys saw properly, but sorry, the videos are a bit fast. We had problems with our vapor escaping because we didn't include holes for the air to go through. And then some fluid mechanics later, we realized that you actually need proper air circulation for the vapor to escape. But yeah, that was done through a lot of testing. This is our avionics system. So we had a beacon PCB, a custom MCU, and a power supply board. Our power supply board was done by my team member, and he actually worked very hard to make sure that it delivered 5 volts at 10 amps, which is a lot of current. We did measure that the current supplied actually got our nichrome wire to, I think, about 250 degrees Celsius.
Wow.
And yeah, these were stacked on top of each other. We had 2 iterations of our custom MCU board. I'll get into that now.
So how long were you guys, what was the timeline for this, like the development process?
Oh, so this was about 4 months.
Awesome.
Yeah, it was about 4 months. 4 months of spending a lot of time at the lab. It was actually very enjoyable, very fun. These are some photos of the challenges. The main challenge was our first iteration of the MCU board. This is what I was part of debugging it and making sure that it flashes. We used a MSP 430, and yeah, that's me working on it. We ran into a lot of different problems because it was our first time like designing a custom PCB. Yeah, a lot of rework wires later, and I think about 2 months of staying at the lab for about 8 hours a day. The MSP 430 flashed. Hooray! Yay. It was like top 3 experiences of my engineering degree. It was amazing. Yeah, and this is us on launch day. It was a success. That's my lovely team assembling the payload, and yeah, it plumed. The vapor worked. We also had a GPS system, and our firmware also worked. It was very rewarding. Yeah, thanks,
Awesome.
guys.
Cool. Thanks, Vibhaa.
Hi. Sorry, I don't know if I missed it. Was the purpose? What were you measuring with the actual microcontrols and all that? Was it just to send up smoke so you could find where the rocket had landed, or?
Yeah.
What was
So
it for?
mainly, sorry.
What was it? What was this for?
So it was like just for the retrievability. We had like a LoRa and a GPS. So we had a working GPS system. We also had a barometer and an accelerometer. I believe I was not on firmware, so I'm not exactly sure how that worked. But yeah, we had sensors working, and we had sensors collecting data, and I think the main theme was retrievability, so we decided to focus on that.
And so you were measuring the performance of the rocket.
Yeah, a little bit, but it was mainly the performance of what actually happens to the payload when it's in the rocket. So I guess like apogee of the rocket and the payload would be the same. But yeah, like the sensors worked for the payload itself.
All right. Thanks.
Yeah.
Awesome. Thank you, Vibhaa.
Okay. Hello, everyone. I'm Tim. I'm going to talk about my lawnmower tonight, which is here. It's also on display over there. But yeah, I've got quite a few slides, so sorry if I'm rushing. But I'll introduce myself to start. So I worked at Crown Equipment in Auckland for several years on forklift automation. About 2021, I moved over to Dyson in the UK. They're pretty secretive about their robotics projects, but they did release this publicly. This is a patent application for a quadrupedal robot that's capable of doing the vacuuming over here. So I may or may not have worked on that project while I was over there. And now I actually live in San Diego, California at Brain Corp on these floor scrubbing robots. We clean commercial facilities, and we're just about to hit 50,000 robots deployed globally. And then on the side, I like a good side project. So I'm not going to talk about this tonight, but this is a little toy truck that can follow a line that you draw in chalk. I've got kids. Ooh. How do I? Sorry. I also have kids, so I bring out the truck at birthday parties, and it's a big hit with the 3-year-olds. I'll try not to hit that. And then over here, a Christmas light map that I made last year. This is 6,000 homes in my local neighborhood, all ranked in terms of the quality of their Christmas lights. I've got a model for that, but I'm not going to talk about that
Maybe
either.
you could make a circuit board.
Right. Anyway, so the summary was I work in robotics, and I live in California where it's sunny, and I like a good side project. So that leads us into explorations of efficient cutting mechanisms for solar-powered lawn maintenance, aka how long would it take to cut the grass using scissors? it's sunny. It's always sunny. It's quite small. So, and I work in robotics, so I should have a robot mowing the lawn. I shouldn't be mowing the lawn. But if you look off the shelf, most of the robots are like really expensive, they're like over $1,000. And if you want it fully hands-free, you need to wire up a dock with power. And I don't want to get an electrician into my rental to wire up a powered dock for this tiny patch of grass. It's all overkill. So if there's nothing off the shelf that suits me, then yeah, we'll just build our own thing. We can say right off the bat that it has to be solar powered. If we want it to be hands-free, but we don't want to wire up a dock, it has to be solar powered. That's the only way I can figure to do it. Okay, so here's some inspiration for solar powered robots. All from YouTube. RC Test Flight, shout out, that's a good channel. Keep an eye on that one. He's done a solar powered rover. Turtle the weeding robot was the main inspiration. That's a solar powered weeding robot. And then over here we've got there are a couple solar powered lawnmowers already on the market. I just found out Sun Scout yesterday in New Plymouth. They're selling solar powered lawnmowers as well. But the main lesson from Turtle, I was listening to a podcast. They're the people who started Turtle are also the people who started Roomba, who kickstarted the whole domestic robot vacuum cleaning market. They were saying when you do a task, you need to think how to do it robotically. Don't just take the human thing and automate it, but rethink how you're going to do it as a robot. And so what does that mean for a solar-powered lawnmower? If you think of a normal lawnmower, it's designed to get the job done as fast as possible. And you don't care about energy efficiency. You pump it with petrol, you spin up the big blade and get the job done as quick as possible. For a solar-powered lawnmower, it's the opposite. You're extremely energy constrained. You don't have much energy. That's the whole critical factor. But you've got all the time in the world. You live on the lawn. It doesn't matter how long it takes to cut the lawn. So then in this environment, what's the best way to cut the lawn? Ooh, stand by to the videos play. With scissors. Scissors are the best way to cut the lawn. At least in theory, they're highly energy efficient. Not that I've measured it, but if you think about a spinning blade compared to this is better. And yeah, okay, maybe it will take a while to get the lawn cut, but it doesn't matter. It's a robot that lives on the lawn. That's its only job. Yeah, so that's where I'm at. And then,
Is this waterproof?
well, it doesn't rain in Southern California. It's like maybe in December you get a 3 weeks notice that it will rain. So it's quite specific to my environment. Do you think I can get another? Yeah. So I'm kind of aware that people see it and think, oh, that's the most ridiculous way to cut the lawn. And they think that's why I'm doing it. And I'd say it's not quite that. It's like, it is ridiculous, but also for my lawn, I think it's also actually a good idea. And maybe, we'll see. And that intersection of ridiculous, but also maybe a good idea is like where the fun is for the project. So that's why I'm pursuing it.
I'm curious about the rate that your grass grows in comparison to how fast the robot cuts it.
So this model, at that speed, if it doesn't do the same part twice, should take 30 hours. So it should be able to get it done in a week. And yeah, that's within the rate of growth of the grass. So yeah, I'll just push that one on. Oh, thank you. So this is the first test of the scissors. I got a design off YouTube and copied it. This is kids trying them out. And we have had no injuries so far with the scissors, I'm proud to say. Nick, can I skip ahead? This is testing the scissors directly from a solar panel. So no batteries or anything, just straight from the sun to the scissors. Here they go. And they're off. They're getting jammed a bit, but you can see they cut quite vigorously. There's enough energy coming from the sun to cut the lawn pretty quickly if you want to. In the other video, the only reason I was going so slow is for noise. I don't want it. This is quite noisy.
Yes.
But there is a lot of power coming from the sun, so it's viable. Lots of iterations that I'm not going to talk about, but I've tried a bunch of different things. Next steps, so it has no navigation system, it just goes straight. It takes 5 minutes to make it across the lawn, and then I turn it around and it comes back. I will need to detect the end of the lawn, inspiration from like forestry surveying. Imagine this is a robot and this is the lawn instead of a aerial LiDAR scan of a forest. I think the same principles can apply for detecting the end of the lawn, or alternatively, the ratio between red and near-infrared light is a good indicator of organic matter. So I've heard about that. And yeah, sheep. So like your
Sheep.
your top-of-the-line lawnmower is going to be using satellites. It's going to be using GPS to mow the lawn to get a good pattern. But sheep somehow are able to maintain an even level without reference to space-age technology. I believe they're looking for the long grass and moving there to cut it. And so if I could do something similar, I think I can avoid the complexity and still get an efficient cut. So in conclusion, I'm at time. So what do we say? So I'm excited to see if this is a good way to cut the lawn. How long will it take to cut the grass with scissors? To the original question, I don't know yet, but I'm excited to find out. Stay tuned. I've just started a blog where I'll post updates, and I'm happy to take questions on LinkedIn, or I'm on the Discord now as well. And that's that. Thank you.
Awesome. Thank you, Tim. Can I ask first, how long have you been working on this for?
I've got a few projects going on, so I don't know. It's been on and off, maybe 6 months or
6 months?
something. Yeah.
My question is, have you considered parallel processing on the cutting mechanism?
What, 2 pairs of scissors?
Yeah, 2 pairs of scissors.
Or more? And pairs of
3,
scissors?
4, yeah.
Yeah, I mean, I like my razor.
Yeah.
I think is like a reciprocating blade, or I have a push mower which has all these blades. The key thing I think is that you want 2 blades pushing against each other.
Yeah.
That's more efficient than spinning up something to high speed so that it can karate chop a blade of grass in 2. That's inefficient. So I don't know if it's scissors long term, if that's the optimal solution, but I'll go in that direction and then iterate and optimize from there.
So I have a follow-up question. Have you seen the rotary scissor mechanisms that they have on some weed eater type machines?
I know like hedge trimmers, but I guess
This is a round thing, but it reciprocates, but it has lots of little cutting edges on it.
okay, maybe I have not. I
Yeah,
might look into
there you
that
go.
one. Yeah, thank you.
Yeah, how many scissors wide is the shortest part of your lawn? Like, could you just have some long arms with
It just
like 20 pairs
slowly
of scissors?
progresses.
Yep. No turning needed.
I'll do the calculations and get back to you.
Thank you. Awesome, sweet. Thank you, Tim.
Okay, thank you.
Just like we saw earlier with the control freaks, we too took part in the PSAT program over summer. So it was me and 4 others there. Overall, it was pretty good success. We found it quite good. So overall, the main goal of the PSAT program was to make it retrievable. As in past years, they had lost a lot of rockets. So we were trying to. Oh, is it not working? Oh yes. Oh yes, right.
Oh, I see.
Just a little bit.
But yeah, so the main goal was retrievability. So we took that as main parts. So we wanted to make sure we had LoRa and GPS, but we also wanted to deploy a streamer in the air so we could see where it is. Along with that, we wanted to make it useful, so we made sure to collect as much data as possible. So yeah, I'm not going to bore you with this. This is really boring. It just effectively says that we want it to work. So yeah, initial ideation. The main issue with this was how do we deploy a streamer when none of us know what we're doing. So we started with a sort of coil mechanism where it kind of is loaded in sideways, and we had a lot of issues. We ended up down in here. This is kind of what we ended up on, where we're pushing a little carriage straight out of the payload. So this is kind of our system overview. It's pretty much just saying we've got our deployables, we've got our all over IMU, location, and just communication. And then so this is our concept of operation. So this is exactly what we're trying to do. Effectively, it was we want to go up in the air, retrieve as much data as possible, and then at some point when we're coming down, we want to deploy our streamer and do all that without wasting any battery. So this is what we consider our first like good design. So we went through quite a lot of iterations, and this is kind of what we landed on. So we can see we've got our compression spring here, and we've got storage for our streamer. This is this is what we iterated on. But yeah, so this was, I can't remember, but this was effectively a couple issues of this, but this was the main skeleton that we worked with. So yeah, going into prototyping, we can kind of see, main progression. It was mainly, the main goal was just making it bigger, get as much streamer as we can in as little room as possible. Overall, it was just kind of just keep chugging. We did quite a bit. We can see down there we had we CNC'd aluminum deploy. Like this is what we call our dart. That's what holds onto the streamer. So we CNC'd our own aluminum dart because we were worried about it like getting tangled in the parachute. We ended up not using it because we figured it would probably fall off and kill something out there. So we decided probably best not to. Then this was our electrical prototyping here. Not a whole lot happened. Mainly it was, so we had two reference PCBs. It was power supply and our beacon board. So that was kind of supplied to us in the program. And then we made our own like main board with all of our sensors. So this is what we can see here. We started on MSP, and then we quickly transitioned to ESP as we went later into the project, just to help make the development timeline a bit faster. And then this is the software. So this is what I handled. We've got kind of three parts in the software. So there was here, this is our ground station. So on the ground, we had our own ESP32, and that was hosting like a little local web server where we could connect through and see the status of our payload. And then on there, we had the firmware of the payload. That was really fun to write because I didn't know what I was doing. So, and then down there, that's our data visualization, so we could see what was actually happening. So yeah, of course, with all projects, we did a lot of testing. And now I want to note this GIF right here. This shows that our streamer deploys. What we'll see later is that same logic was clearly not that great. But yeah, so launch did work, which was great. It was great to see that it actually went up in the air after all that work. And then, yeah. Oh, where are we on? Where am I? Okay, I'm going backwards now. What's happening? Okay, yeah. Landing site, yeah. So this is a bit of story on this one. We kind of got yelled at by the main organizer of the thing because we were taking way too long and people weren't able to launch. But I like to say it was not our fault. We kind of landed in the worst possible spot I think you could have landed. There is a nice stream going right down the middle here. And our GPS was saying we're on the left side of the stream. So we spent about 45 minutes out here looking for it, completely confused why we're in an empty paddock and couldn't spot a big rocket. Turns out there was a little hill that was covering it perfectly. So yeah, we got a nice long walk around to go find it, and got a bit of a telling off for it.
It sounded like you needed like a little smoke plume to tell you where it was.
Exactly, yeah.
Maybe you guys should team up.
So main results. We got everything worked, all the firmware was working, except our streamer did not deploy, which is weird because we tested that more than we tested anything. We can see it working in that top right there. We believe it was the fact that we just used probably the cheapest servo motor you can buy, and we put it through its paces over the 4 months. So it was probably the main reason for us not working, but that's all right. Everything else was a success, so we're pretty happy still. And yeah, we can see the success here, mainly with our graphs. So these are, don't know what happened to that text, but that's all right. So we've got, so these are our main two graphs here. And the thing is, one thing we'll notice is it kind of teleported, and we don't really have an explanation because all of our other data looks pretty much fine except for a couple outliers that we didn't remove. But it teleported, and we don't really know.
Magic?
Magic. A couple wormholes must have opened up for us or something, but yeah, because 500 meters in half a second is pretty
With the amount of sellotape and hot glue in this thing, I feel like it could do anything. So.
Yeah, honestly, yeah. And then, there's more graphs for you. We've got kind of just all of our stuff going on. The main only notable thing is probably the spike here. I guess our altimeter was doing something funky that day. We never really saw anything in testing, but yeah, that's when the rocket opened. So I guess something along with that line. But yeah, overall, happy. We got what we tried to do, and we got, so we did everything we tried to do, and overall, good success. Yeah.
Was it barometric, the altimeter? So when it opened, it measured a change in pressure as opposed to... Could that explain it, or?
Yeah, probably. I didn't do the component selection, I'm going to be honest, but it must have been something like that. I can't remember exactly what we used, but it would probably that would probably be it. I'd have to check with the avionics guy who isn't here tonight, unfortunately, but yes.
In the 500-meter gap, could that be explained by jumping between satellites, or is that? I mean, it seems way too far.
Yeah, that's actually a great suggestion, actually. Yeah, I don't really know. From my understanding of GPS works, I'm sure someone here knows a lot better than me, but probably not. Yeah. I would go with, but I'm not really sure.
Awesome, thank you, Reid.
A year ago, I was here pitching a hardware product that I was trying to sell. And I found prototyping that in Auckland really, really hard. So I've decided to solve that problem. I'm creating a makerspace specifically for people who are prototyping and doing small production on products. It's called Common Workshop.
Have you got any kind of equipment so far that you're thinking about?
Yes. So there's going to be metalworking, electronics, woodwork, CNC router, what else? Fabric stuff, and just sort of general assembly tables and painting. That's it. Yeah, it's just
awesome.
A shed with stuff in it.
Yeah, very cool stuff in the
and
very cool
people
shed.
like you.
Exactly. Awesome.
So yeah, Common Workshop.
Sweet. Thank you, Alex. Specifically, Alex spoke at our last nerd night with his cool chair. You said you couldn't find enough customers. That's so sad. It was cool.
Hello. I'm Scott. So PAQ Labs, which is in the lab right behind you guys on the corner there, has a really cool role coming up for a master's or a PhD graduate, ideally in mechatronics engineering. The project itself is based on computer vision. It'll be full mechatronics, so part selection, mechanical design, software. Really interesting project. If you're interested, either come chat to myself, or there's QR codes on the blackboard or the lab space itself as well. So definitely check it out. If you yourself or someone you know could be interested, really cool role, fully paid, 6-month contract with opportunity to extend. Yeah.
So it's the one down the bottom there on the left.
Yeah, bottom
Buzzy
left.
bees.
Yeah, buzzy bees.
Yeah.
All to do with honey testing and pretty groundbreaking lab testing automation. So super cool project.
Awesome. Cool. Thanks, Scott.
Cool. Thank you.
Chris, yay! There's a new project. So
Yeah.
Chris is well known for his light-up train circuit boards.
Train map stuff. It's been keeping me too busy. This project was done this afternoon, partially because I'm too busy at the moment. But it's a name tag, so it's got a 3-color e-ink display on there. It's the kind of stuff you get at grocery stores and stuff now. Weirdly cheap. It's I should have not gone for a 3-color one though, because it's really slow to update. It takes like 10 seconds to refresh the screen and does not do partial updates. I should have read the AliExpress listing. Anyway, it's now got a CO2 monitor on there, so that is the background CO2 level, and it updates every minute. And I'm surprised I'm not the only one, but this is a battery from a vape that I found on the side of the road. They're surprisingly good. Anyway, it's all put together with hot glue. It's just a simple 3D print I did in Fusion 360, chucked it together, and it's got an SP32C3 in there. Yes, it's not a power-efficient chip. We'll see how long the battery lasts this evening. It's still going. It's been going for 6 hours. Also does not have a power switch, so yeah. It's a flawed thing, but it's cool.
I'm speechless.
Hi, my name's Matthew. I did not know what to expect. Scott invited me, and so I was like, oh, okay. And I thought, well, since it might be a little bit of a show and tell, what could I make to show and tell? So I took 3 days off of work to try and make something really quickly. This caught my eye. It's a Sensron, basically environment sensor, so particulates, VOCs, carbon dioxide, temperature, pressure, basically the whole shebang. Even one of the other versions has another molecule that I don't know what, but it is able to produce. But I thought it was kind of cool that I remember at university we had a lecturer who wanted to do exactly this, but it was in a box that was about like this big. And now you can get a little module that big, and just adding a LilyGo screen to the front, space for the battery in the back, you got a whole contained unit. So I thought that was kind of cool that, just things advance really quickly. So yeah, it doesn't work right now, of course. That's always happens, but thanks.
Awesome, thank you. I actually made a IoT pollution sensor when I was 16. It was about this big, so definitely not as small as that. I put one like inside a house and one outside, and it was quite interesting that you could tell the amount of pollution that like came inside. Yeah, lots of cool stuff you can do. Awesome. Tristan, welcome up.
Cool. Hey everyone, just wanted to get my seat next to you for once in a while. Talofa lava everybody. I'm Tristan, and I work with a team of excellent high school students organizing New Zealand's largest high school-led hackathons for 13 to 18-year-olds. And it's called Kiwi Hacks. It's on my shirt here. Maybe you needed binoculars to see that. But I just wanted to give a quick primer because we've got an amazing high school student who won one of the prizes at our competition named Leland. He's got a PhD in keyboardonomics, as you will find out. And yeah, we're doing some really exciting stuff. So please pay close attention to everything he's going to show you tonight. Interact up there at the showcase after this. And we've got some big plans. We're running Auckland, Wellington, and Christchurch, aiming to get 100 plus high schoolers at each of those 24-hour hackathons. So if anyone has any friends down in Wellington or Christchurch, please, please, please talk to us. We had the privilege of having quite a few of you in this room be our mentors at our last hackathon, and we hope to see you at the next ones. Thank you very much.
Awesome. Thank you, Tristan. Krishna. How many years has it been?
Quite a few.
Like 8 at least. Yeah.
So myself and Mikayla actually worked together for OMG Tech.
Yeah.
And big part of my life has been sharing things I'm interested in with young people. And also, I'm not formally trained. I'm a dude in a shed. And a big, huge part of my life has been skateboarding. Very long story short, it was watching a friend make the decision between the guardrail at 80 kilometers per hour or the jagged rocks on the other side of the guardrail coming down Mount Ruapehu. And all of a sudden, in a flash moment, I realized I need to look at the way I'm skateboarding. I was ending up in hospital. And so the first thing I did, do we have a clicker? Was I electrified my skateboard. Could someone just hit play on this video? I electrified my skateboard purely because anything powered has a speed limit.
Press the exit sign. Should it work? Yeah.
And so this is what I used to do when I was allowed to. High-speed riding, my terminal velocity is just under 100 kilometers per hour.
Wow.
And these are now a couple of my team riders in Quebec. And essentially, we're just trying to make it down the hill without something going horribly wrong. Pack riding is really common, and we're hoping to make it into the Olympics.
Wow. That's awesome.
Hang on, I'll get back to your slides now.
There's only a few of these, so that should make it a bit easier. Yep. Okay, so I started out by building skateboards. I couldn't buy what I needed on shelf, so lots of composites, going lighter and lighter, not because it makes you go faster, because I'm lazy and it's easier to carry up the hill. Oh, do I point it? Oh. But pretty soon I realized that I didn't like the way carbon fiber made me itch, so I really got into designing the trucks, the metal parts. Rather than, and this is a really stupid decision, rather than buying a house, I took my deposit and I bought myself a 2-ton CNC mill. And
As you should.
As you should. My neighbors in the area I lived hated me from there on in, but I'd started designing bespoke trucks. So I would work with a rider, I could watch how they were riding and tweak a parametric model and then make a customized part for each rider. I also got old. So another big reason for getting into electric skateboarding was because the doctors are basically telling me don't have much cartilage left in my knees. So by avoiding pushing, I started to design an electric system.
I hated electric skateboards. Being a downhill rider, I thought it was really lame. Battery technology, motor technology, everything caught up, and I have to admit that now it is super fun, and what I'm working on is what I call electric assist. So it's still a downhill board, I'm still trying to be light, but if you come to a part of the road that isn't as steep as you want, you can jam your accelerator and you can keep that high speed. The other benefit is you can skate back up to the top of the hill. Obviously I design everything in Fusion. And just having a quick look, 3D printing my hubs, again for modification. I can change my gearing and just print out new hubs. So this is the part that connects the motor to the internal of the wheels. And this technology is really achievable for anyone. It's off-the-shelf electronics. You don't have to spend too much. Sometimes I see electric boards are in the sort of $4,000-$5,000 range, where really the components that go into it, apart from the battery, are maybe $500. So cramming everything into a 3D printed box, and everyone's more than welcome to come and check out what I've done up there. It's on the table. As always, I never catted in the wires, so it's always that last stuff to get the last things in the box. I can see a few other people have fallen into that trap. The other thing I ran into in New Zealand was a really frustrating issue of the fact that I would send out turning to get done by shops, and they would take it on, they would do one job, and they'd say, oh yeah, it's only $10 an axle. Then the next time I'd send it, oh, actually we've had to raise the price by $30. And then all of a sudden in the third batch, oh, we're raising it again. And I realized what they were doing is they were looking at what I was selling these trucks for and deciding they wanted a bigger cut of the pie. So being that I'd blown all my money on my mill, I decided to turn... Oh, actually, sorry. Can you hit play on that last one? This one here? Yep. Oh, it doesn't matter. Long story short, anyone who knows about CNC milling, we spin the tool, we keep the stock. I've flipped it. We put raw material into the tool holder, and it gets turned on a setup. So basically what I just wanted to demonstrate is that, you know, if you get creative with what you've got, didn't need to spend another 60 odd grand on another piece of kit, didn't have the floor space for it, but I managed to make it work with the machine I had. I also set up a home anodizing line, and that's just a matter of having an electrified bath of acid. Neighbors also hated me even more at this point. But what it did was it allowed me to have custom colors that nobody else in the skate industry has, and custom colors for my riders, so they could specify not only the geometry and the ride feel, but they could get the look they liked. Lots of Arduinos chucked into there for temperature control. Actually, one of my favorites for anyone out there doing this sort of thing is Roast Logger. It's a coffee roasting project. Yes, I've got a home coffee roaster, but for doing anything where you're monitoring or wanting to keep temperatures stable, cheap. This was a video. Anyone who doesn't know, it's pump foiling. This is now my new offshoot because, oh yeah, that one should just play. Pump foiling is where you've got a wing under the water and you use your body motion to create forward drive. So 2 years of failing miserably, and I'm getting to the point where I'm about this good. But also, we're coming into winter, so my new project at the moment is... Oh, if we just come back. I know for next time. New project is making an electric e-foil. These things like 20K, I don't have that sort of cash to blow. Again, simple off-the-shelf components. We're talking about 2 or 3 grand worth of gear. So on my hobby desktop CNC router that I've loaned out to a school, I've machined some foil molds. These are getting laid up at the moment. And I'm working towards fully electric foil and a foil assist. So rather than having to pump, just jam the motor.
Awesome.
The next goal after that, once that's all completed, is this has been a long-standing thing I've talked about for a long time, but I'm also, as a ex-surfboard shaper, I stopped because of the amount of rubbish I was putting in a landfill. It was all polystyrene, it was horrible. I could never bring the two things of loving the ocean and creating 6 sacks of dust before my board even touches the water. So I've been teaching myself mushroom growing because the root structure of mushrooms creates a organic biodegradable foam, and I just need to get the weight right, and I think I can I'm confident that I'll be able to grow my own surfboard within a year or two. Yeah, awesome.
Sweet, thank you, Krishna. Awesome.
I am interested in your e-foil. When you were making the foil itself, how did you decide what shape to first make? Did you just a random one that you found on the internet, or did you simulate it in some way?
Again, it started a bit random, but what I've found is there's a hobby freeware simulator that does the wings of RC planes. You just change it from being normal air to being really thick air, and essentially you turn the tail fin into the mast, and you can get a surprisingly accurate model. In reality, I think what I'm going to end up doing is borrowing a friend's 3D scanner and finding a wing that I like and just scanning it.
Let me know when you do that. I'd be interested as well, because
awesome.
I've also gone down that route and just never took the plunge because I didn't know how, I didn't want to deal with the wing and everything.
Yeah.
But yeah.
Definitely. For anyone who wants to keep track of me, I'm Robot Oblivion on Instagram. I've kind of dropped off the face of the earth the last few months just because I didn't have a space to machine, but hopefully in the coming few weeks I'll be back up and running. So that's Robot Oblivion on Instagram, or I'll hang out over here for anyone who wants to chat skating after the event. Awesome. Cheers, everyone.
Awesome. Thanks, Krishna.
Hello. This is the world's worst keyboard. This was made during a 24-hour hackathon.
Kiwi Hacks.
Yeah, Kiwi Hacks. So Kiwi Hacks was a 24-hour hackathon where you build cool hardware projects, and this is one of them. So the idea was to make a keyboard very painful to use, that it makes you appreciate every single keyboard you've ever used. So what's in this thing? So there's a microcontroller. There's a button. There's a display, and there's a potentiometer.
Potentiometer keyboard.
Yes, unfortunately.
Oh no.
So it connects via Bluetooth. So you connect it, you turn the knob, you select whatever letter you want, and you click enter. It's easy to use, but that comes with its trade-offs. So how does it work? You twist the knob, you get an ADC value, you map it to the character index, you draw on the display. If the button's pressed, you send it via a keystroke via the Bluetooth. The specifics, this is a ESP32 dev kit, 30 GPIO pins, Bluetooth, Wi-Fi. There's an OLED display with an SSD1306 driver. There's a 10K potentiometer, and there's a button.
Awesome. Those jumper cables are holding on for dear
life.
life.
They are. Yeah. Here's the code. There's 116 lines.
What's your favorite part about it?
I don't have a favorite part. I don't really like.
What's your least favorite part about it?
I mean, we were gonna make a case and make it look nice, but we didn't have time to 3D print and model a case for it.
Mm-hmm.
Yeah.
So ideally, you to improve it further.
Yeah. To improve it further, probably build out a case, like design a case in Fusion, print it, put the stuff on. Yeah.
Awesome. So can you do all the characters or only a select
yes,
few?
it's only like letters, no backspace.
Oh no!
If you make a mistake, it's over. A lot actually goes into your keyboard, so do appreciate your keyboard. I mean, this type of technology is like there's like so much stuff online about this.
What's the longest thing that someone typed? No, how long? Yeah, what is there? Is there a length that you can type?
You can type whatever you want on it.
So you can type something infinitely.
Yeah.
Okay.
5. Maximum is 5. The average is about 2. And the lowest someone's gotten was a couple words per minute. No, sorry, a couple minutes per word. Yes, a couple minutes per word. Yeah. Yes,
Yes.
It's very easy to clean. Just don't dip in water.
Yeah, not very waterproof.
Or else-
That seems to be a
yeah.
theme tonight.
Yeah.
Awesome. Sweet. Thank you so
Yep.
much, Lee.
Lee, what are you looking for next?
Like, as in. The future. Oh yes. If anyone wants to give me a job on internship,
Yeah.
I'm willing.
You're still in high school, right?
Yes, I'm still in high school. I'm 16. Okay, maybe not a job, but an internship anywhere. I just think this stuff is cool. Yeah.
Awesome. Well, what do you want to do when you're older?
Probably comp sci or engineering.
Apart from the case, what would be an upgrade you want to do to this keyboard?
Add more characters, add numbers.
And a backspace?
Yeah, add a backspace, definitely. And just, sorry? It's all lowercase, so no caps. The next thing would probably to give it polish, like more of a polished look. And I think 240 megahertz of CPU is way too overkill for this. So,
My question is, how could you make it worse? I've got an idea. You could have a random shock, like you never know when it's going to happen. So while you're typing,
it kind of does that. And also, while you're typing, it does drift. I don't know why. I don't know how. But it does drift. So it just adds to that good typing experience.
So in your eyes, you wouldn't change anything because it's already
yeah,
terrible.
Yeah, exactly. Yeah.
What if you had to spell space to make spacebar?
That's a good idea. Yeah. We should add that.
I like that.
Same with backspace.
Yes.
But that has space in it. So you need to save it too. And put it in a room.
Yeah. Oh, you don't want autocorrect on this, trust me. You want to suffer.
Well, no, but what about you could make a terrible autocorrect, that would
Oh,
purposely
sure,
give you the.
Sure.
Awesome. Do we have any other questions or suggestions?
A suggestion to make it worse: introduce a randomizer.
Yeah, that's a good idea. It already kind of does that. It jumps. Sometimes it jumps around randomly.
Yeah, so to use up all the processing power you have is run a LLM on it and have it suggest the next character as well.
that could be a good one. Yes, definitely.
And then you have to cycle away.
Yes, Kiwi Hacks, which was the hackathon. They're really good.
Yeah, I'd agree.
Yeah.
So thank you, Kiwi Hacks.
Yeah.
Yeah, and if you guys want to help out Kiwi Hacks, that'd be great.
Yes, please do.
Awesome. Cool. Thank you so much, Lee.
Please give me that internship.
Please give him an internship.
All right, so my name's Andrew Burns. I'm an engineer, aeronautical engineer, but I've worked in production line machinery, I've worked in train brake systems, I've worked in aerospace, I've worked in medical devices, and now clean tech. But I'm also an artist, a photographer and a printmaker. And I mostly work with alternative printing processes, which are kind of like 19th century chemical-based handmade prints. So I guess the moral of the story is that you can be more than one thing. You can be 2 things, you can be 3 things. People generally think that engineers are, I guess, not very creative, but that doesn't have to be the case. And I think actually creativity is a huge advantage for engineering as well. Yeah, so alternative process printing, they're sort of typically historic printing processes. They're usually hand-coded, usually chemical-based, and I guess the main thing about them is that they're normally made by exposure to UV light. So where the UV light impacts the chemicals, it makes a chemical reaction or some kind of change, and that's how you make the print. So why would I want to print this way? I mean, mostly because I can, to be honest, but because it's fun. It's an interesting technique to play with, and I don't like inkjet printers. So if I can avoid using those, it's even better. Typically, to make an alternative process print like this, you need to have some kind of negative, like a transparent negative. You put that in contact with the sensitized paper and you expose it to UV light. And the areas that get exposed through the negative get a conversion happening, and the ones that don't. The main thing with this process though is that the negative is actually in contact with the paper. So of course you can't make a print which is bigger than the negative. You need a negative the size of your print. That's called contact printing. So there's a few ways you can make a big negative. You can use a gigantic camera, and that's kind of like what people would do in the past. They would just use a huge camera. But the modern way of doing it these days is to print on transparency, and then you could print as big as you want, but then you have to use an inkjet printer, which again, terrible, hate it. Another way of making prints, like from back in the day, is the darkroom. You would use an enlarger. So an enlarger is kind of like a projector, and you just project light through a negative and optically expand it to a bigger size print. The downside with that is, though, that all these alternative processes, they all use ultraviolet light, they don't use visible light. And they also need quite a lot of energy. So, enlargers were good for silver gelatin prints, which can use visible light and don't use much of it, but it was kind of physically impossible to generate enough UV light to use an enlarger until recently. And if you tried, you would melt the negative. You just make too much heat. So it's technically possible these days, but it's kind of only just becoming possible. So what did I do? Well, I thought I don't want to contact print. I don't like inkjet printers. I want to enlarge, but I don't want to use negatives either, because then you have to have film, and I like digital cameras too, so I thought, well, I'll make a digital projector. So essentially, it's kind of like how older TV and movie projectors would work. You'd sort of have a light source, you'd focus it through a transparent LCD screen. I mean, the thing is that most LCD screens are transparent anyway, it's just they have a white backlight. You'd display an image on the LCD screen and you'd project the image, except in this case it's UV. The LCD screen is like an 8K monochrome screen from a 3D printer, like a resin 3D printer. So quite high resolution, and it's good with UV light as well. The downside is that those LCDs only let through 4% of the light at best. So a completely white screen is 4% of the light. So 96% gets turned into heat, you can imagine. So to get a reasonable printing time, I had to use a 400 watt UV LED, water cool it. And obviously now you have 300 plus watts of heat at the LCD screen, which you've got to cool as well. So just a shitload of cooling, a ton of power, and still 1 hour exposure times or more. So that's just some more pictures of the build. You can see the water-cooled LED on the right-hand side. There's the LCD screen in the middle, and kind of the frame with the lenses and things on the left-hand side. But yeah, so I did a bunch of prints. I had an exhibition at the upstairs art gallery in Titirangi. You can see some of the prints over there. I've sold half of them. The other half are kind of on my wall or sitting around. But yeah, it was good. I mean, it's a pretty simple process. These are cyanotypes, which is kind of it's Prussian blue as the pigment. You mix sort of chemicals together and it forms that blue print color, but toned with coffee. So you paint coffee onto it afterwards and it turns more of a browny sort of purpley blue. Yeah.
Are you still selling any of your prints?
Yeah, I mean, I still have a few. I have a website too, which I can tell people afterwards, but it's sort of more or less a kind of thing where my website has pictures of what I'm making, and if you like them, just contact me, basically.
Awesome, cool.
Yeah. The one over there is spoken for already. So the next thing I'm working on is carbon printing, which is a different kind of process. So you essentially mix gelatin with a photosensitizer, and you mix a pigment into the gelatin. You pour it onto glass plates and kind of let it set. Then you expose the gelatin, and it selectively cross-links in places where it gets exposed. And then you put it through a developing bath, which is just hot water. The hot water melts away the uncross-linked gelatin, leaving the stuff that was cross-linked behind, and that has the pigment. So that's kind of how you get your pigment tones. And you can use any kind of pigment you want, so why not CMYK? So my current plan is to expose 4 different glass sheets for an image, a CMYK glass separation, then stack the plates on top of each other and you just backlight them. So you'll get a color image, but they're physically separated by the thickness of the glass plates. And then as you look at it from different angles, you'll see the colors sort of shifting in and out of alignment to each other. So
That's awesome.
yeah, it's kind of a fun, it draws attention to the printing process and how color prints are actually made, and it sort of, engages the people watching or looking at the print into the print as well. And I do kind of like the, I guess the circularity of modern technologies for making like PCBs, for making silicon chips, lithography, screen printing. They're all, they're originally derived from artistic processes. So those were all art processes before they were used to make PCBs, and then they were kind of used to make technology, and now technology is making art again. So it's kind of like going full circle.
That's awesome.
But then disaster.
Oh, oh no.
So if you know LCD screens, that should be totally black, but it's not. So I have that screen over there so you can have a look at it. But basically, if you know how LCD screens work, you have polarizing screens that polarize the light. Those screens use like organic dyes. Those dyes bleach. So huge amounts of UV light bleached out, screen no longer works. So I can't make those prints anymore. But the solution is more steps. So what I'm doing currently is using a similar LCD screen and a camera to make a film negative of a digital image and then projecting through that film negative. So it works quite well actually, it still works the same way, but it's just more steps. So the good thing is that A, it's way more efficient. So my exposure time went from 45 minutes down to 8. But also if the film negative gets damaged or burns or whatever, then I can just make another one. Yeah, it's just more work.
Thank you, Andrew.
Did you consider the DLP chips, the ones with the little mirrors?
Yeah, I went through DLP. The problem with those though is I wanted at least 4K, if not more. And 4K is kind of already expensive, but when you look at what they're rated for in terms of the power levels, because they're way more efficient, so you wouldn't need as much power. But even so, if you ran them at the same sort of powers I would have to get a good exposure, they have lifetimes in the order of hundreds of hours or thousands of hours. You can get UV rated ones, but they're not, they're super expensive. And the visible rated ones, their lifetime just goes down orders of magnitude at UV wavelengths. Yeah, I talked to some of the manufacturers of them, and it just wasn't possible.
Thank you so much, Andrew. That was
Thank
super
you.
interesting. Cheers. Righty. Thank you so much to everyone for coming. This is my favorite event we run. I think it's just so wholesome seeing what everyone's getting up to in their spare time. So thank you to all our sponsors. So we have Outset, Learn Digital, Triode, and Braymac. So thank you to our sponsors. And also a massive thank you to our volunteers that helped set up today, the committee that helps support Hardware Meetup, and a big shout out to Miguel, who's been helping me run this event. So thank you, everyone.